Hello, this is Benjamin Flagg. I'm here with Brendan Flanagan. This is for the Tournamental project, and this is the May 2021 version. This is the pair programming project where we took my feature, which was a power meter, and then implemented some different mechanics from Brendan's features of the many he had. We decided to go with the actual variable that my power meter captures, implementing a feature where his feature where you could actually hit the ball. We also did to where if the ball lands on a water tile, it will reset to the starting green. If the ball goes on the hole tile over here, it will actually register that you have won the game and display a winning splash screen. And as well, we created a player pawn child to hold a lot of this new functionality and a golf ball blueprint object just for the actual golf ball to register its location, stuff like that. So I guess we can go ahead and I will show you how we implemented this. First, let's see. I'm going to go ahead and actually.
Yeah, what do you want to show them first? The water,
I'm going to
maybe?
give a quick preview. Just a quick preview, and then we can go because it's a lot easier if we show the functionality. So this on-screen widget was my
show them
initial,
what you already had.
Yeah. So this was my initial feature. Basically, you can hold down an input, and it will register a float range on screen. And if you hit space, it will capture that, but it actually is applying that percentage that it captures to a selection of different golf clubs you have here. They have a minimum and maximum value, so it takes whatever club you have, the minimum maximum value range, applies the percentage that this progress bar captures. And initially, it stored it in a variable, and that was kind of it. So it was a power meter and club selection system. What we added, Brennan actually had another version of a club selection system, but he also did have a system of actually hitting the ball. And I believe it was just kind of like a input random integer base, correct?
Mine ran off of a random integer between 0 and 100, and I figured since your power meter was running off of a float between 0 and 100, it was relatively easy enough to implement my math straight into yours, since we both also had predetermined club distances.
Definitely.
So I didn't have to try and do any hardcore math to determine a club distance, since you were already doing that with your meter. So I just gave you a ball that was able to intake that distance and know to move that amount.
And that is one thing that I think one of the reasons why we partnered up with this is just kind of knowing Brennan's had a lot of very cool in-depth systems, and mine to fit into something like that, I wanted to get it to where basically this entire thing just comes down to one variable, basically.
And that's exactly what it needed. That's exactly what it needed to do.
And definitely required, obviously, some tinkering with implementing code, but it actually worked fairly well. We didn't really run into any issues other than just normal, we forget to connect a node here, or we had to try something new, but it went fairly smoothly, and it was a lot of fun.
And actually, because Ben already had his blueprint capturing an integer for how many tiles to move, whereas I did that math in the player pawn, we did have to do some things differently in order for the ball and the player pawn and hit Ben's existing blueprint all to know how far to send the ball. So there's a lot of referencing, get all actors, get a copy, setting a reference, and then using that reference to, for events and changing variables on other blueprints. And it's a little bit of stitching together, but it worked.
So, it did. So real quick, I guess, I was going to
say, with no further ado, give it a shot. Go and get yourself in the hole.
Okay, so let's say if a player was to start, basically just choose a random club. That club will have that range. You'd go up, hit it, it would store the value. So we added this ball. And you can see there, when I did that there, that's actually a sphere trace that Brendan created in his. And then we implemented it in here. It's checking to see if the ball is on the same tile. And if it is, it will apply this hit swing power to the ball. And then there's some math that we can go into in the actual code here. But here's an interesting example of what the water hazard does. disappears and it
And
resets the ball.
resets.
Yes. So water is punishable. Now, try and not do that. Oh, also, we did, and this was another feature of Brennan's that actually came in really handy for this ball hitting mechanic, which is being able to rotate, so you don't have to constantly be circling around like a shark around the ball. So
Like a shark, yeah.
Let's do this and see if we can get
It
that
also
ball.
made it so that if the ball was ever quote unquote stuck up against the wall, you can stand on it and put it away from the wall. So just like
Ooh,
that, whereas normally
so
that
close.
could have been potentially game breaking. Nope, now you can just stand on it and put it away from the wall.
Yeah.
Or down the wall. That works too.
Wait, I don't know. I might have it here. Actually, I might have to
No.
do this because I can't move it away from that wall.
Oh, what do you mean? You have the rotate. We were just talking about that.
Oh, you're right. See, this is where this mechanic comes in handy. And as you were saying it,
I'm like, no, that's what it's for.
yeah, no, that's really good. Actually, that didn't even come up during our. I mean, I'm sure it did for yours, but that's really cool.
I mean, that's the whole
It's cool
reason why I
finding out
made
this
it.
stuff
Yeah.
during this. Yeah.
I didn't want to have ever the player be broken because the ball is stuck up against the wall and the ball needs to go the opposite direction. So I figured it would be best for the player to be able to stand on the ball. Which actually, going into the ball, it is a child of the obstacle blueprint. And instead of using the interact through the forward vector, it's using the interact through the negative on the up vector. So that's why it's looking down for the ball. And the tile is enterable, which is why the player is able to go on it and stand on it and look for the ball, as opposed to being outside of it looking for it to interact with it.
I will say too, just from testing, it actually works pretty well. Not necessarily my course design, but the way this moves and some of the club selection distances, like not very good, but we can get there.
I just want them to be able to see that we did indeed program it all the way to the splash screen when you finish.
One cool thing too that was part of the feature that Brendan had, like I had a hold that was not functional. He added the functionality, but it actually
was a lot
register.
simpler than you thought.
Well, not only that, it's cool that it actually requires you to. You can't just hit the ball and have it go over the hole. Like if you overshoot it, it literally has to behave like a real golf ball, and you have to land it in the hole at the end of that.
Yeah, you could. Like, even if you're lined up with it, if you driver forced over the hole, it doesn't just blink into the hole. It'll just go right over it.
And it does require you to use the actual clubs that you should be using. I mean, again, apologies for not being very good at my own here, but let's see. I can go over two. Yeah. And then it will display you win. There is a restart game widget, and it restarts the game. Yeah, so that is the kind of long-winded version of that, but there's a lot cool stuff that I think we were able to implement there. So I'll really briefly kind of go over some of the stuff that we added.
Yeah, and I'd say overall we did this in about 3 hours. We worked from like 5 to 8.
Yeah, I'd say.
I think right after. Yeah, I'd say from about, or maybe 4 to 7, something like that. But
it might have even been longer, but I think the longer part was shoring up code that we really wanted to get. Yeah.
It was getting your integer getting all the way through from your blueprint originally down to the ball.
Yeah, even though it is a variable, it's still pairing up those systems. It wasn't it didn't immediately work, but it was also a lot of fun, and it worked.
It was a very fun. It was a very fun bit of because he already had half of my systems already there with his distance.
So. Okay, so this is for my original power meter blueprint. All of my functionality, other than the actual widget blueprint, is in this. All that we added to this was at begin play. It will spawn the player pawn child at the end of all of my normal calls to set up variables, local variables.
Not spawn it. It'll get it.
Oh yeah, I'm sorry. It's getting a reference to it. And then down here on the basically this is just my golf club arrays for the selection. But down here on the actual setting of that swing power, which right now you hold shift, it'll raise and lower the power bar. You press space while holding shift, it'll lock in that power. We added a new final swing tile distance variable just to not only kind of even more simplify that final result, but just clarify it, do some extra little bit of different math to get the systems to pair up a little bit better and functioning. And then we fed that into swing set input.
And that swing set input actually feeds directly into the pawn child. So now, so when you actually collected the distance that you swing on that blueprint, it then feeds it over to the pawn child.
Yeah.
The pawn child feeds it over to the ball.
Which is right here. And that's basically right here. This is my original variable. It's doing some extra functionality and then adding it to that child. Like Brennan was just saying. This here is just on tab. This was another feature that we implemented into mine, which is that rotation function. It just gets the actors, or the actual self-reference, and then sets that rotation on input, which right now is tab. Okay, and then down here.
This is that actual input. Yeah.
After that, right here, once it calls swing, it hops over here. It is basically the sphere trace is checking right here. Actually, it's looking to see if that ball, the golf ball blueprint object, is on the tile that the player is on. It uses a sphere trace to do that. Just checks right at the player pawn's feet, and if it is, it applies that final hit variable that we just set up and captured. And then also using that blueprint that I set up with that widget. So that is what's happening right here. It's getting location, setting that, breaks it down, does some extra little bits of math here. This hit ball, a lot of this functionality is actually in the golf ball itself, but that is what it's calling here.
And that's the calculated integer that came from the blueprint power meter. So there's its handoff.
All the way over
you can see it's stringing all the way down and all the way into it. And there's the handoff of it, so the ball knows how far to go.
And then we just have a couple delays and resets here of some of the different meters and power systems because it has applied this, which we will show in a second. That is here. A couple different things here. Up top, pretty much just getting references to a lot of those different things just to make the code easier. Especially here, current location, start location, whole location. That is a lot of the math involved in finding out where the ball is and what to do with where it is. Right here, this is a custom event. If the ball hits a collider that we added to the water hazard, so it has this now, it will call that function.
It's a nice simple one where it just says on overlap, if the other actor is the ball, then tell it to call the water reset function, and it's as simple as that.
And that is, here is that actual event hit ball that we
and there's that integer. There's the most important integer of the game. Being passed along straight into the actual math into the lerp so that it knows where to go.
Which is basically, a lot of math, a lot of cool stuff that Brendan was able to design, and then we were able to implement it. And just with that pairing of that power meter with his systems that he had that checks for all of this and applies the actual motion of the ball and the checking of the tiles really worked out well. So a lot of this is just repeat code, just with different directions. It's checking for each one of those, checking for vectors. I'll just kind of go over one of these here. So, it's getting the current location, doing some math to figure out where the actual end location is going to be, and then it applies that over a float curve. Just kind of get a nice smooth motion of that ball moving from where you hit it to where the variable decided the distance in tiles is going to be. And it will do a check to see if it's going to call, is that ball reset from water? Did it hit one of those water tiles? If it did, it is going to reset the actual ball's location to the start location, which is the player spawn, basically the T.
Yeah, just a pure reset.
If it didn't, or once that animation is finished, it's going to do that check again. And if it does not hit a water tile, it is checking to see if the tile that it's on is equal to the hole location. So did you make it in the hole in that final pit? If you did, it's going to display the last thing that we did, which is a splash screen. Victory splash screen will pop up on screen, basically letting you know that you won, and that's when you had that ability to restart the game if you wanted to, which is
booyah.
Let's see. I think
I'm just happy that it was something that you were able to make, something that you already put in all the math for, do all the coding for getting your integer to go up and down, or your float rather to go up and down on screen, and getting the player to choose it. And then we were able to do some things that I already figured out, and then use the thing that you put the hard work in without having to alter it at all, and plug your math straight into this system.
It was definitely the process was for sure more of just random technical things like oh, this node we need this node, but the actual framework, it pretty much, once we got the right code execution, it was like, oh, it works pretty well. So it was really cool. I think it turned out good. So hopefully that can be a sneeze. But and I think
very nice.
That pretty much covered. I mean, that's a lot of cool stuff that we were able to implement from Brennan's into mine.
Yeah, and I don't think we missed anything. I think we covered up, got all the things that we did add to yours.
I think so. All right.
That's very nice.
Would you like to show?
I shall swap over.
Now, yes, here. Going to end my stream sharing.
Alrighty. So I'm Brendan Flanagan, and of course you were just watching Benjamin Flagg, show off all of his cool features in his golf game. And I was lucky enough to be able to receive his power bar into my game. And the first thing I'd like to do is actually go straight into that blueprint widget. The first thing you'll notice is it's nowhere near as pretty as his. He had a nice.
Yeah. That worked out good too, though, because I designed it knowing that UI was just vanity stuff, and I wanted it to look nice. But if people don't want to use that, the functionality is still there. So.
And I'm happy that yours, has that touch of your personality on it, whereas mine is just the pure functionality. So sure. I appreciate Ben passing off that functionality. So the first thing we did was set up this progress bar, and Ben showed me that you can actually set a progress bar to fill from bottom to top. That's the first time I've ever messed with that. I know how to set up a horizontal bar and set up little text things, but this is actually the first time that I realized I don't have to set up an editable text bar in order to change this. So we bound that up, and let me go over the graph. And we got a couple of simple functions. This is where we actually take the power bar meter and lerp it between 0 and 1, kind of just over and over again, up and down. And then we just append a percent onto that. Actually, well, this is already going up and down on its own. That actually doesn't happen here. But as it goes in, we multiply by 100.
And to get that, instead of it being, to get that 0 to 100%.
Yeah, so that this down on the bottom is actually tracking what's happening in here. So as this is going up and down, this is live tracking what's happening there. And I don't think I changed anything of the color in here. I think I tried to, somewhere.
Is it?
Yeah, I tried to set the color here and there, power bar color, but even though I set it to green
that actually should be part of it. Yeah, is that the binding event? I believe. Yeah.
Well, I think we ended up doing just the lerp color right here.
Oh, that's right. Yeah, because mine was in my power blueprint, and we had to do it in a player. Yeah.
Exactly.
So yeah.
So because you have your blueprint that's not in the player, yours just is a standalone blueprint showing what's happening on screen, and that's where you're also doing the math. Mine is in my math is all in this club determined distance, but we're not going to get into that because that's not what we're worrying about right now. I wanted to show off what Ben showed me. So in order to add his power bar, I had to give a new left shift event node, and I had to switch over my rotation over to tab, which is fine. And his already knows to capture spacebar, so luckily where I was already coded to hit the ball is where I had to add some more code where his has his it's like it traps the generated power when you hit space. It stops it and traps it. And then we know, is the power bar meter set? Yes, we check it. So going back up to the top though, this is the timeline that is bringing the power bar up and back down over every second, just up and down, up and down. It's lerping its color as it's also going back and forth. It's lerping its color, lerping its value, and then you got that percent text that knows to take its return value and set itself up and down. So going into the spacebar, like we just said, the first thing I had to do was add his power bar active. Is it active? First of all, we got to make sure it's active before we even do anything else. So that's the first thing that happens off of hitting the spacebar. If it is active, we stop it and capture its generated power. We know that the power bar is set. Now this is some things that I've already included in here. This is checking if we just swung. It's actually kind of the same thing as is power bar active, but not really. This is just basically making sure you're not spamming swing on the golf ball.
Yeah, it's kind of like some slight, very closely related stuff that just needed some tweaking to mesh the two.
Because technically they're kind of looking for the same thing, but they're not exactly looking for the same thing. So we just kept it all. So this is where I determined my distance. So I thought it was cool that his did the power bar and the distance all in the same blueprint. So I actually had to try and emulate that by making sure that I was getting the power and the distance in the same blueprint. This is just checking for walls, and then this is where I actually pass my calculated distance off to my ball, depending on the wall or the actual distance. And this is what Ben has. This is what I had to give to Ben. This is where I actually check below the chest, basically looking at your feet. Is there a ball that implements the interface? And if so, hit the ball. These are things that I already had, and just to make sure Ben's things are all working. If there is no ball, false, we reset the power ball. So same thing, you can't just spam swing. And then we also have the power bar set. We change that back to no, it's not set because 2 seconds have passed. And also reset the power bar meter so that everything can just go on to the next swing. So with all of that being said, we're able to see it in action. So like I said, it's nowhere near as pretty as his, but it works the same way. We both have very similar gameplay now that we have a power bar and clubs that all have variable distance. So while our maps may be different, it's pretty much the same gameplay.
Your course definitely is a better testing ground.
What I did with my course is actually I took it off of a website that builds courses for people's backyards.
Oh, interesting.
So it's not really a PGA golf course or anything like that, but it does the trick. It's a fun enough course. And now that you can actually control the power, it's so much easier to get what I think is about to be called an albatross.
Oh, yeah, that's the one I don't know. I know what an eagle is.
-3, yeah. So, I mean, the swing power, honestly, I could probably start bringing par down a little bit because back when I'm not even going to play right now, but just to show the UI, back before I had the random integer, instead of saying power needed 0 to 24, this and that, it just said percent chance of this happening. What's your chance of going 8? What's your chance of going 9? And it was 25, 50, and 25. So when you read this, it said, okay, I have a 25% chance of going this distance, 90% chance of going this distance. So I didn't really change the percentages per se, but as a player, you have much more control over what those distances are because that percentages is now just a power that you are in complete control of. And I think it's a very much more intuitive and interactive, and the player feeling like they have much more agency instead of feeling like every time they swing the club, they don't know what's going to happen.
That's where, I think our systems ended up working out good. And we didn't even really, we didn't communicate about this before or anything. It was just I used a very similar initial system before the actual percentage code was in my own thing, where I also had just grab a random integer, display it on screen so that I know it is getting the right club's right ranges. And that is, I guess, where this did implement into this pretty well. And vice versa is now it's like, okay, it actually is skill based.
Yeah, now it doesn't just feel like a random uh, golf game. It definitely feels more of like, okay, hey, I can choose not only my club, but I can choose how hard I swing it, and choose my route in the level, or whichever you want to do it. I just feel the agency really comes alive once you give the player that interactive power bar.
You really start thinking about your club selection and trying to hit the right time too.
hmm
Right.
Now, generally, I did keep my statistics simple on my club. I'm sure you might have noticed that all of the distances are only a array of 3. They're actually not even in arrays. I just have like
Okay.
they just know. um, I figured if I made it more than 3, it'd make my daisy chains a lot bigger and stuff. And I did code up to like 8 result daisy chains for my drivers and stuff originally, but then the web was too much, and I decided that, well, not too much for me. The way I saw it is, if I'm going to pass this on to someone else who's eventually going to have to deconstruct it and decide if they want to use it, 3 is a lot easier. And if they want to make a bigger daisy chain, they can.
Yeah,
Um,
I
but I
think
like how yours does it,
worked
because
out.
yours never has a daisy chain. Yours just pops out the tile distance, and then you just use it from there.
Yeah, it's just checking that percentile on the clamped range of the golf club value stat values, and then which I guess is kind of why this, in my opinion, worked out well. Is you had a lot of this functionality for like a golf game, and then just basically that
And you
skill
have,
input. And I had not that, but I really wanted to see what would happen with my power meter if someone implemented it. And now I can hit a ball with it on my end and actually like score. So it actually is a course now on my golf
yes.
course
And I
functions
know,
just
I
because of
know
that.
you, I know you have enough, skill and experience in here to be able to add more widgets to your not widgets, add more buttons or text or whatever to your widget blueprint at the end when you win. I know we generally kept it simple on your side, but at the same time, I know you have the ability to expand that as much as you'd like.
Definitely, yeah, and then other people's courses, if on that reset level, it just could game or the manager could just go to another course after you get the ball in the
hmm
hole. Um, so there's a lot of hopefully open-ended functionality that other students and developers and instructors hopefully can pull from if they like any of what they see.
Yeah, I'm very happy that I was able to get um, your thing right in here, and I thought it was a very cool experience being able to see how you did it in a blueprint that wasn't necessarily on the player, but because I had already put so much functionality on the
Mhm.
player, I needed some of that functionality already to feed into that system. Instead of making my own blueprint, I just put that functionality straight onto the player. And then, while that might have been how I did it on my end, we had to do it different on your end because you didn't already have the functionality in the player. You already had it somewhere else. So we had to have your player talk to that blueprint. And at the end of the day, like, our games do play very, very similar, but they are under the hood not exactly working the same. So I think it's a very
It was a
cool
lot of
experiment.
it was a lot of fun doing this pair programming like I think came up with the 2-person 1 computer or wait no 2 I can't remember that but where you're not sharing files, you're not sharing code, you're literally just trying to walk someone through the logic and getting it to work, and I think we both had a lot of fun doing it. And
Yeah, and
yeah.
it was definitely a nice little experience also in my own code, like when I was going through and it's like, okay, what does he need from here in order to get this to work? So as I'm going through this, or was going through this the first time, I'm thinking to myself, like, okay, he doesn't need to worry about walls right now. Like, that's not, like, you weren't asking me for a wall collision. You were asking me for, hey, can we get a ball to detect if it's in a hole? So I just skipped over all this and was like, okay. And then calculated distance. I'm like, wait, he already has a distance calculator, so he doesn't need this either. So
It's
that's why
like
I only had to
yeah,
start giving him stuff from here out.
we didn't even talk about our features that we chose till after we chose them, but it kind of ended up to where Brennan, I think, pretty much just needed a swing power meter feature, and I kind of just needed a conditions of victory to test my, and it worked out that is what we both chose, not knowing the other one chose that at the time. So that
the amount of calling of getting actors and me setting them up, like I got so used to doing that on my end that when I showed Ben how to do this stuff, he ended up getting used to doing that. And then, me learning how to better handle integers and not integers, lerps going up and down between 0 and 1, and understanding that that's actually can be represented as a number between 0 and 100 as long as you multiply it by 100 somewhere, which I do right here. And it works out very well.
I think so. There's a lot of get call actors of class because of our different things, but just it's part of the fun. But yeah,
this is honestly one of my, like, this right here, this little lerp doing the color changing, and like at first me being like, it's not changing this color, and until we decided to just add this little, well, not add, you already had it. So to you, this was something that was really normal, but then it just made my life so much more like satisfying.
I like that too, just because if a solid color is hard to tell over that little amount of time where it's landing visually, versus you don't even necessarily have, you can look at it if you're peripheral.
Exactly. You can like keep your eye on the ball more, which you don't even need to really do because it's a game.
But turn-based. But
it just feels better that you're not staring at it, and you could just look off to the side, and then okay, red, that's full power, bam, you could hit that.
And then hopefully, with the part of the theme that they're we, I guess, as a team are all aiming for, mental is that the after the fact, like the next day, what if I would have done this? What if I would have done this? In normal golf situation, like, hey, what if I would have not taken the riskier shot? What if I would have used this club? What if I would have swung it? So hopefully that meshes well with all of that too. But I think, yeah.
I think it's, like I said before, the player agency, the amount that this actually feels like a game just from adding that power bar, really opens it up, and it doesn't feel like you're just hitting buttons. That interactive up and down feeling of that float constantly changing and the player having to time a choice really does make this feel more well-rounded.
And hopefully too, yeah, maybe future students or people can take that core functionality and then find some really weird, interesting, fun, cool, unique things to do with that, especially with level designs. I'd be excited to see what people do with that. Definitely want to check in for sure.
Well, I don't think I've got anything else to show off. I know my other videos show off everything else, so I'm pretty happy. I'm content with what has been shown here. Anything else you want to add, Ben?
I don't think so. Just to really enjoy the project, honestly. It's enough where I know not just me and you, but I think a lot of people in Discord have asked, not just as part of the team, but on our own, just mess around. Everyone immediately wanted to keep kind of messing with it, which is why I think this is cool. Once you see everyone else's ideas, and then you get to pair with one and see, you start to really get the whole picture of, oh, wow, this really could come together with a lot of cool systems, and then it gets your brain thinking. So enjoyed it. That I think we pretty much covered it though. So I would just say thank you for your time. I appreciate it.
Yeah, whoever may be watching, thank you very much.
All right, thank you.
Take care.